Hi there, I'm Heather Bedle, and throughout my career in the geosciences, I've seen how critical amplitude versus offset analysis is for identifying hydrocarbons and characterizing reservoirs. However, my colleagues and I have often encountered limitations with traditional AVO methods, particularly in complex geologic settings with multiple layers and varying porosities. In our recent paper, we introduced the rotated distance and quadrant RDQ crossplot, an approach that addresses these long-standing challenges in AVO analysis. The foundation for our work is the DQ trace attribute, which converts every sample to the equivalent of a peak or trough, and this allows us to maximize the information we extract from seismic data. Unlike traditional methods that only analyze peaks and troughs, our approach utilizes all the seismic samples. Through the development of the quadrant enhancement and sector expansion, we've dramatically reduced the overlapping of shale data points with the wet and gas sand clusters, a persistent problem that's frustrated AVO analysis for years. Our method requires no prior knowledge of petrophysics, borehole data, or basin geology to generate the initial analytic displays, and so this means you can begin your AVO interpretation earlier in your project's timeline, using these insights to guide further investigations. In our testing, we've demonstrated the workflow's effectiveness across all 4 AVO classes, showing superior separation between wet and gas sands within each class. We've also discovered linear trends in RDQ crossplot displays that correlate to variations in thickness, porosity, lithology, and pore fluid. I'm particularly excited about the DQ theta px attribute, which can delineate fluid contexts even in challenging Class 1 dim spots where traditional methods often struggle to identify hydrocarbon presence. While we focused on synthetic models to establish theoretical foundations, we're already seeing promising results in real-world applications. Our team is currently working on additional case studies that we'll be sharing in future publications. If you're working in exploration or development, I believe our methodology could enhance your seismic interpretation capabilities. We've included detailed methodology and examples in the full paper to help you implement these techniques in your own work. So this paper was recently published by Interpretation, and I encourage you to reach out if you have any questions about implementing these techniques in your projects. You can also find more details on the ASPE website. Thanks for listening.